Hello and welcome to the second Quikport tutorial. In this tutorial we're going to use Quikport's input wizard to very quickly input a single span portal frame building. So let's start Quikport. Okay, Quikport's loaded. To start the input wizard we click on this icon here. This is introductory text. To move to the next form we click next. Okay, the first thing we're going to do is to create a project folder, which I shall do here. You could create it outside of Quikport just using the normal Windows way, but I'm going to do it within Quikport. We'll click on the Browse button and we'll create it under My Projects, New Folder, and we'll give it the name Tutorial and click OK. And OK, and it's entered it into the path into here, so we'll just click next. OK. Now this form expects us to enter the bay centers down the building. We could just enter them into this list, but as always in Quikport there's an easier way. So I click the Auto button and we'll have the first bay center at 6 meters, then 5 at 6 meters, and then the last one at 6 meters. Click OK. And that's popped them into the list. Now if we wanted to change any of these, we just select it and then right click and we've got options to change any of them. Okay, and we're going to have a single span portal frame. Click next. Okay, this is going to be our basic geometry of our portal frame. Here are the basic frame shapes. We're going to do a dual pitch portal. I'm going to have a 12-degree pitch. The eaves level I will put in is 4 meters. The base level at minus 0.3, and a span of 24 meters. Next. Okay, this form is asking us about the base types. It's defaulted to a nominal pin. If you don't know what nominal pin bases are, then as always in Quikport you can click on the help. This describes how the form operates, and then this text here will tell you all about nominal bases. Now these defaults are set really to help the designer, and a nominal base of this type is what's normally used in portal frame design. So I'll click next. Okay, this is the haunches form. Again, the default 10% of span and use best depth. If you want to know more, the help will tell you. So this is the details for the left hand haunch and the right hand haunch. You can see the haunch red in the diagram as we change it. We're going to click next. Okay, this is the purlins form. It wants a list of purlin centers down the rafter. Again, Quikport has an easy way of doing this. We'll click the Auto button and this form is shown, and it's asking for the first center, then 2 at 1.5 and the remainder at 1.8. Now these are defaults and it will actually remember your defaults. I'm going to accept these and click next. And then I'm going to say I want that on all rafters. Finish. So this is the left hand rafter. You can see it red here. And this is the right hand rafter. I'm going to click next. Exactly the same. This is for the rails to the column. So I'm going to click the Auto button. And I am going to have my first one a bit higher than that actually. So I'm going to have it at 0.75. We can imagine there's a dwarf wall there. And then I'm going to click next. And I'm going to have it on all columns. Finish. So that's the left hand column. And that's the right hand column. And I'm going to click next. Okay, simple form. We're going to create our loadings in accordance with EN 1991. Note there's a little note here about 5502 Part 22. So if you are doing an agricultural building, it's all covered. I'm going to click Next. These are the imposed roof loads. Again, these defaults are pretty good. You will need to change these occasionally. If you do want to change them, all you do is highlight it with a left click, then right click, and we've got this same pop-up menu where you can change them. And this is the form. I'm not going to change them in this example. The only other thing is this radio button selected here says automatically include self-weight of rafters and columns. Fair enough. Next. And this form covers the snow loading. So we're going to have a site location, Pool, Dorset, and we'll put an altitude of 20 meters, and the snow zone is from Eurocode's National Annex is 2, which is what is set. Now we can view the calculations. These are the calculations for the snow load. Close and click Next. And now we're on to the wind loads. The input wizard will automatically apply the wind loads. It's taken the altitude from the previous form. The effective building height it knows because we've input the geometry. Now the wind velocity. Looking at the wind map, I think for our area we can put 21.7. We're right on the coast, so we'll leave that as it is, and again we can view the calculations for the wind. And there's the pressure, 0.78. Close. And we'll click Next. Now this form does nothing really other than we have an option here. We could, if we used another source of wind pressure, the Breathe program I believe is one, we could override that and type in our own value and what have you. There's a few defaults here that we could change, but we're not going to. Most people don't. Okay, next. These are the wind coefficients around the frame. Quikport's worked all these out, and we can see, I think we can make this form slightly bigger. Yeah. So these are the net pressure coefficients at the end. The table, and as we click in the table, we can see the panels around the building changing. And this is for wind direction 0, 180, and 90. And we could even spin this actually, but anyway, stop. Okay, now you won't normally need to change these coefficients, but you can. The other one that you can change, of course, is the internal coefficient. Next. So we could apply it to the current surface, or we can apply it to the whole span and what have you. But again, we won't do that in this example. I'll just talk about, here's the view report. So it's a full explanation of the coefficients, all the tables, all the information is here, and a description at the top of what it all means. Let's click Next. Quikport's warning us that not all values of CPI have been entered. Are the defaults correct? I'm going to click Yes. Okay, this is a brief table of deflection limits. You can change or add more deflection limits or delete them. You can do whatever you want here. Click Next. Okay, that concludes the input for our first portal frame. So what Quikport's done here is it's produced a frame file for each frame down the building, starting with gable 01 and moving down to gable 08. Now usually it's the penultimate frame that's critical because of the way the wind works, and in this instance from the loadings we can see that is in fact the case. Now at the bottom here, it's just a few notes is to telling you how to proceed after Input Wizard. So that's done, so we can finish. And Quikport's now opened up that frame on the screen, and we can sit. I don't know why it went sideways there. I think I clicked something. Never mind. So we can see here are the deflection limits that it's applied. These are the loads. We can change the load case here to view the actual loads applied to the frame, and the notional loads, etc. All set up by Input Wizard. We can't go further with these because we have not yet added any sections. We're going to cover that in the next tutorial, which will be all about Design Wizard. Thank you for watching.